In the last two chapters, we've discussed utility maximization from the graphical perspective and from the perspective of the method of Lagrange. And now in this video, I present a frequently encountered example in microeconomics that should illustrate this approach. Previously, we've used a general functional form for the utility function, so we didn't specify a specific functional form for u of x1 and x2, and now we will change that and then solve the resulting problem using the method of Lagrange. So let's again assume that the consumer can buy two goods, x1 and x2, and the utility, felicity, satisfaction, whatever of the consumer is captured by the utility function that we have here of the amounts of consumption of the two goods, where the amount of consumption of good 1 is raised to alpha and the amount of consumption of good 2 is raised to beta, and alpha and beta are parameters that are in between 0 and 1. And these parameters reflect actually the effect of consuming the particular good 1 or 2 on utility, or in other words, it captures the taste of the consumer. For example, if alpha is quite high and beta is comparatively low, then the consumer would like good 1 more than good 2 and vice versa. To simplify things a bit later on in the utility maximization problem, we can use the logarithm of this function instead of the function directly, because the logarithm is just a monotonic transformation, so we do not really change any maxima or minima by that. So if we take the logarithm, things become simpler, they become additive. So we have that alpha times the logarithm of x1 is the first component, plus beta times the logarithm of x2 is the second component. So the utility function would then be logarithmic, but still, as we see, concave in the consumption of both goods. So if we increase the amount of consumption of good 1, then utility increases, but at a diminishing rate because we have the logarithm, and the same holds true for consumption of good 2. With respect to the budget constraint, nothing changes to the previous video. We still have M as the amount of money that the consumer can spend. The price of good 1 is P1, the price of good 2 is P2, and the budget constraint is that everything that is spent on good 1 and everything that's spent on good 2 must not exceed the available budget. Then we can state the problem formally. What we do now is to maximize alpha times the logarithm of x1 plus beta times the logarithm of x2, subject to the choice of x1 and x2. And the whole thing is subject to the budget constraint, so that we do not spend more than we have in terms of money available. So that's the formal problem statement, and we can immediately set up the Lagrangian function. We have the utility function here, this expression, plus the Lagrange multiplier times the right-hand side of the constraint minus the left-hand side of the constraint. So that's then the associated Lagrangian function for this particular utility function, this logarithmic utility function that we have here, which is nothing else than the transformation of the function x1 to the power of alpha times x2 to the power of beta in terms of logarithms. The next step is to compute the necessary first-order conditions for an optimum, and we already know that this is taking the partial derivative of the Lagrangian with respect to x1 and setting it equal to 0. So we see here that this is equal to alpha divided by x1, because 1 over x1 is the derivative of the logarithm of x1, minus lambda times p1 from here, because this term and this term here do not include x1, so they drop out. That has to be equal to 0, and we can reformulate it and isolate x1 as a function of alpha divided by lambda times p1. Then we do the same with the derivative of the Lagrangian with respect to x2, so that looks very similar. We have here beta over x2 minus lambda p2 from here is equal to 0. We can isolate x2, which is beta over lambda times p2. And the derivative of the Lagrangian with respect to the Lagrange multiplier, that's again the constraint that we get from this. And then we can solve the three equations that we have in the three unknowns. The three unknowns are x1, x2, and lambda, and we can solve for these three unknowns, where usually the solution is expressed in terms of x1 and x2, while lambda is eliminated. So what we get here is that if we take together this equation and this equation, we can reformulate and write alpha plus beta as x1 p1 times lambda plus p2 x2 times lambda. So if we bring the lambda p2 to the left hand side, right? So then we get the left hand side of this expression here and the term in the middle. And then from the budget constraint, we see that this expression here is nothing else than lambda times m. So therefore we can already express lambda as alpha plus beta divided by m. And the interesting aspect here is that this result has already a very intuitive interpretation. The Lagrange multiplier, as we know, gives us the increase in utility that we get if we relax the budget constraint slightly, so if we have slightly more budget available. And this utility increase would be the sum of the two preference parameters, alpha plus beta, which measure to which extent utility increases if we can consume more of the two goods. And it's divided by m, the available budget, because the higher the budget is that we already have, the lower is the additional utility that we get, and that's simply a consequence of the concavity of the utility function. So we have that utility increases in consumption of good 1 and good 2, but at a decreasing rate. So the more budget we have available already, the less additional utility we would get by a slight relaxation of the budget constraint. And that's what we have here. So we have already expressed lambda now in terms of the parameters of the model, alpha, beta, and m. And then what remains to be done to get demand for for good 1 and for good 2 is just to plug in the Lagrange multiplier in equations 1 and 2. And what we get then is consumption of good 1, x1, as a function of the available budget, the price of good 1, and the preference parameters, and the same holds true for consumption of good 2. These are the so-called Marshallian demand functions for x1 and x2, the Marshallian demand functions being functions of the available budget and the prices. In this particular case of a logarithmic utility function, we see that only the price for the good that we are considering matters. So there is no cross-price effect. So the price of good 2 does not matter for the consumption of good 1, and the price of good 1 does not matter for the consumption of good 2. And that's just a consequence of our logarithmic utility function. For more general utility functions, you would see cross-price effects. So Marshallian demand is the demand function depending on the budget and the prices. And we see that it is very intuitive, this result that we have here. Demand rises when the available budget increases. So that's clear. If we have more money available, we can afford more of the consumption of good 1 and more of the consumption of good 2. So consumption of both goods would increase. By contrast, if the price of the good that we want to consume increases, that would reduce our consumption of this good. So if P1 goes up, we would reduce consumption of good 1, and if P2 goes up, we would reduce consumption of good 2. And finally, the third result is that the demand for a good increases if the preference for this good rises. So that's nothing else than the statement: if we start to like a good more, then we would consume more of it. We see this here. So x1 depends positively on alpha, but negatively on beta. And good 2, by contrast, depends positively on beta and negatively on alpha. So if for some reason our taste for good 1 increases, so alpha increases, we would consume more of good 1 and less of good 2. And if beta increases, the reverse would hold true. And now all of these statements that we have here are actually very intuitive, and they are very much in line of how most of the people would behave in terms of their consumption behavior. So if they have more budget, they would buy more goods. If the price of a good that they want to buy increases, then they would reduce demand for this good. And if their taste for a certain good increases, so they like it more, they would increase consumption of this good and perhaps reduce the consumption of other goods for which the taste did not increase, so which they do not like better. Now, what we can also do is from equations 1 and 2, we can get again our condition that we had earlier, that the ratio of the marginal utilities must be equal to the price ratio. In our case, the ratio of the marginal utilities is alpha divided by x1 divided by beta divided by x2. So that condition needs to hold, and it's the well-known condition that we already have for utility maximization, that the marginal rate of substitution needs to be equal to the negative of the price ratio. So the rate at which the market allows us to exchange the two goods must be equal to the marginal rate of substitution that we have for the two goods at the point at which we choose to consume the two goods. Our example, however, goes on and can present the explicit solution of the utility maximization problem, in our case as the Marshallian demand functions. And what we've also seen is that a rational optimal behavior that lies behind this is actually quite intuitive and leads to quite realistic results. So if you like a good more, you would consume more of the good. If you have a greater budget, you would like to consume more of the good. And if the price of a good rises, you would reduce its consumption. So nothing of that is really going against any intuition. So this rational behavior assumption that is behind the whole thing seems to describe the behavior of most of the people reasonably well. Of course, it does not imply that we economists assume that somebody goes to the supermarket and solves Lagrangian functions, but the result of the whole procedure describes the behavior of most people reasonably well, and therefore we put some weight on such a method. Thank you very much for watching the video, and I hope you found it interesting and useful. For more videos on economic content, please visit my channel that you find here to the left. And to the right, you see the next video in the series at the top, and at the bottom, you see the whole lecture in the form of a playlist.